Hello, good morning.
Morning, sir.
Yeah. Okay. Yesterday we started understanding the hashing techniques, and hashing techniques will really help you in searching the required data from the table at much faster rate, because it will avoid you the sequential comparison which is required. Whenever you want to store data into the hash table using the ID, okay, uh, pass the ID as argument to the hash function. Hash function gives you a key, and at that particular key you go for storing the record. And whenever you want to retrieve a particular record again from the hash table, so you'll be knowing the say example we took yesterday was the employee ID. You'll be knowing the employee ID, passes the employee ID as argument to the hash function, and it will generate the same key again, and you just go to that particular index in the hash table, you'll find the record. Okay, and then we understood what is a perfect hash function is. The perfect hash function is the one which will always generate the unique keys, but in reality, so there will be the collisions. Okay, so it is very difficult to perfectly build a hash function which gives the unique key. Now, how to resolve the collision? This is what we were discussing in the yesterday's class. So there are two methods: chaining method, another one is open addressing or linear probing method. So, and the other two complex methods are double hashing and quadratic probing. So we'll focus on this. I think quadratic probing and double hashing is not there in your syllabus. We have only the chaining and open address and linear probing. So first we'll focus on the linear programming, a linear probing technique for avoiding the collisions, and later we'll go for understanding the chaining method. So because the 12th lab program is based on the linear programming, linear probing, we'll finish this first. Now this is very easy. The linear probing is very easy. So first let me explain you the problem. Okay, you can just let us consider this example. With this example we'll try to understand what is linear probing is. So these are the records which I want to insert into the um, hash table. So, and I have the hash table of size 10, you can see here. So initially we'll put the following keys in the hash table. So 131, 4, 8 and 7. Now 131, when I'm doing hashing with simple division method, when I'm using with the modulus 10, I get it as 1. So 131 occupies the position 1 in the hash table, and 4 takes the position 4, and 8 takes the position 8, and 7 takes the position 7 within the hash table. So now for instance the element 131 can be placed at this one, and this is how it goes. Next, 131 is giving you the result 1, and hence it is placed there. And now say I want to place the 21. So 131 I have done, I have done 4, I have done 5, I have done 6, okay, and of course 8 also I have done, I think. 8 is also done. 8 also we have inserted here. So next my focus is on adding the record 21 into the hash table. Now when I again find out the hash key for the 21, it is giving me 1. Okay, so but the index 1 location is already occupied by 31. So if you just observe here, see 1 is already occupied by 31. The collision has occurred now, because 21 should also be placed at the same place, and 131 is already there, and there is a collision. To resolve this, we will linearly move down, and the next empty location will probe the element. Okay, what we have to do now, whenever there is a collision, what linear probing does is just keep searching for the empty location, okay, linearly. Okay, so you start from here, so and just look for the empty location. So empty location is found at the index 2. Okay, so this was empty earlier. So if I go back, see this is null, that means nothing is stored there. Now I can go for storing 21 there. This is what is linear probing is. So whenever you compute the key, and for that key in the hash table, if there is an element stored already, so then you can simply go for performing a linear probing. Okay, just look whether there is an empty location in the next position. So now when I looked, so I found the empty location, and here I'm inserting the 21. And similarly, if this is also occupied, then I go for linearly probing the next location. So like this I keep continuing until I find the empty location linearly. Okay, hope you understood.
Yes, sir.
Okay. So next, what we have done, see, we are taking 31. Now after placing 21 here in the second position, okay, now what we are taking is the record 631. Okay, 31 and 61 are taken. Okay, so I go for again computing for the key for the 31. What it gives me is 1. Again it says this is already occupied. Now again I linearly probe to the next location. Yes, 21 is also already occupied. Let me go to the empty one. Yeah, this one. So 21 is already taken. Now I check with this full, and then I check with this the next location like by linearly probing. So this is also full, and when I linearly probe for the next location, it is null. That means so 31 will come here. Okay, 31 takes this position. Next I take 61 to insert. So 61 also results in the keys 1. Again I start from here. So I check with 31, 131. Okay, 1 location 1 it is occupied. Location 2 is also occupied. So 3 is also occupied. Next I probe. So 4 is also occupied. This also occupied, and I have the next position at 6. Now 61 will take the 6th position. You can see here. So this is what is linear probing. Okay, and then we are done with 31 and 61. Next, where do we place 9? Okay, so I'm taking 9 right now, and when I find the key for the 9, okay, by performing the modulus operation with 10, I get it as 9, index as 9. Okay, so 9 gets placed to this position. So that is there in the next this thing. Okay, 1 second. So 9 gets placed over here. Okay, next, and now see the it is full right now. Okay, so from except the 0, the rest all have taken their positions. 1 to 9 are filled. Okay, now say to next number, see everything is placed. Let me see what is the number that is not placed. So 131 is placed, 4, 8, 7, 21, 5, 31. 5 is also placed, I hope. Yeah, 5 is also placed. 5 is also placed, 31, 61, 9 is also placed. The last number to place or insert to the hash table is 29. Okay. Now when I again compute the key, hash key for this 29, I am getting it as 9. Let me come here. Okay, 9 is already occupied. Now if I just try to find out the next position, okay, so I am just trying to find the next location, because 9 is, since the index 9 is already filled with the number 9, I just linearly probe for the next location, and it is not there, because that is the end of my hash table. Now this situation, what we call it as the overflow. The overflow occurs. To handle this, we move back to the bucket 0, and is the location over there is empty, 29 will be placed at the 0th index. Now see this 9, and if I try to linearly probe the next location, it is not available, and this condition, what we call it as overflow condition. Now when overflow occurs, we will try to make it so something like a circular queue. Move back, correct, no? After 9, instead of going to 10, we just move it back to the 0, and again we check. In the 0 it is null, correct, right? Now to 29 will take this position. So 29 will take this position. So and the problems with the linear probing is, so formation of clusters. It leads to the formation of the primary clusters. How? Say for example, this is my hash table. Now I want to insert the elements. These elements I need to insert. I am finding the keys. So now you can see, so the 39, okay, just a minute, I have to start from here. So 19, so when I do the modulus operator, what I am getting it is 9, so 9 got inserted over here, 19 got inserted over here, and next 18 is the one which I've taken. Okay, modulus 10 I do, so 8 I'm getting. Okay, so it gets inserted over here. Okay, and then 39 I'm getting, so modulus 10 is giving me 9. Again it says it has to be inserted here. Okay, since there is a collision, now we linearly probe for the next location, and since there is no next location after 9, so there is a overflow. Now to solve this, we again move back to the initial position. Okay, so we move back to the initial position and we have the 39 placed here, and 29 modulus again 9 it is giving. Now I come to this position, so again this is occupied, so again linear probe I do, overflow occurs. When overflow occurs, I go back to the initial position, so again in this 0th position we have 39 stored, so and I search for the next empty location. This will be empty. Now this is occupied by 29. Next 8, something like this. This is a cluster formation. See here there is a cluster, one cluster, and there is another cluster formed, and this the rest of the table becomes empty. Okay, it is not sequential, something like this. So this is what the simple table which you have taken. You can see two clusters formed here. So if the ash table is very big in size, then you will get a number of such clusters formed, and here and there, in between the table will be empty. Okay, and this clustering problem again can be solved by using the quadratic probing, but this quadratic probing you don't have for your syllabus, so we will not be discussing about the quadratic probing. OP people understood the linear probing?
Yes, sir.
So it's easy. Linear probing is not at all a difficult thing. So you'll be having the hash table with the fixed size. You take the elements to be inserted, so compute the hash key. Simple, very simple hash key we are computing, that is by using the division method. So and just go and check whether the index at that, within the hash table that particular index is empty. If it is index, you insert there. In case if it is not empty, so and if there is a collision, instead of saying if it is not empty, what does it mean? So there is a collision, that means there is the same key generated for the one more record. So what you need to do is, if there is a collision, you got to linearly probe the next location. Okay, so keep doing this until an empty location is found. So when you're in the process of doing this, so you may encounter overflow. That means you may not find any empty location, and you may reach the end of the hash table. So how to address the overflow condition? Again, going back to the beginning of the hash table. Okay, so hope this is clear.
Yes, sir.
Okay, now the chaining, the other method we have, the chaining. So we'll go to this chaining method after discussing the program. Okay, lab program, 12th lab program. So today I'll finish this lab program, and even that lab program is also easy, just like the DFS program what you did. So it is not even a lengthy program. So we'll just discuss this program now. Yeah, so let me go through the question first. Yeah, say given a file of n employee records with a set k of keys, 4 digit. Okay, so you'll be given the employee records, some employees, n employees, and each employee has an unique identifier, and that unique identifier is a 4-digit number, which uniquely determine the records in a file F. Okay, so I have all the employee details stored in the file. Okay, so we are not giving file as the input here, don't worry. Okay, assume that the file F is maintained in a memory by a hash table HT, okay, of m memory locations with L as a set of memory addresses, 2 digit. Okay, so that means the hash key which you generate, it should be of how many digit? 2 digit. But the employee ID is of how many digit? 4 digit. Okay, the hash key what you're going to generate, it should be of 2 digit of locations in the hash table. So let the keys in K and the addresses in L are integers. Okay, so that means you're not going to read anything as the string. Develop a C program that uses the hash function. Okay, so hash function is also given. See, very simple hash function it is. So hash of key is equal to K mod M. Okay, where M is the length of the hash table. Okay, so the employee ID mod the length of the hash table. So the length of the hash table here, it has to be 100 because he says 2 digit, 0 to 99. 0 to 99 is 100 employees data. It should provide a provision for you to store 100 employees data, 0 to 99. So 2 digit. So and implement the hashing technique to map a given K to the address space L. Resolve the collisions using linear probing. Okay, so this is what the program is. The question looks little complicated, but it's very easy. Okay, now we'll try to understand the program, then we'll go for the execution. Hope you understood this question.
Yes, sir.
So you have to read the employee ID as a 4-digit number, and that 4-digit number you got to convert it into an hash key of 2 digit. And what is the hash key function you have to use? The employee ID mod M. So here M value will be 100 because you got to generate a 2-digit hash key from 0 to 99. Okay, now so header files. Okay, and then see, we have taken it as 100 because since it says 2 digit, the hash key should be of length 2 digit. So how many employees data I can store using this 2 digit hash key? I can go for storing 100 employees data. So I'm taking a macro max, I'm initializing it to 100. And then these are the function prototype, because within our program we have 3 user defined functions. One is the create, another one is the linear probe, and one more is display. So create is taking an integer argument, and linear probe, so this create is basically what it does is it goes for inserting the employee record onto the hash table. Okay, and this is the one what I pass here to this create is the employee ID. So this create takes the employee ID and then goes for generating the hash key. And then in case if there is a collision detected, so then we make a call to the linear probe, and we linearly probe the next locations within the hash table until we find an empty location or we reach the overflow condition. If we get, when I'm doing the linear probing, if I get an empty location, I will be inserting it there. In case if I don't get the empty location and if I reach the overflow condition, so linear probing will again make me start all the way from the beginning of the hash table. So and again when I complete the process, if there are no more, and it cannot, because since it is a 2 digit and what we have taken is also 100, so it should work fine. Again, in case when you are again starting from the beginning of the hash table and if you reach the overflow condition, again your hash table is full and it is not possible for you to insert. And we have one more for displaying the content of the hash table. Okay, so from 0 to 99, and there are 2 ways we go for displaying here. 0 to 99 also for the entire hash table as it is we display, and other way is we go for displaying only those rows in the hash table which are filled with the employee records, and the rows which are null, so we go for skipping. So 2 ways of displaying we perform. So OP people understood till here?
Yes, sir.
Okay, next is the main function. So have a look here. So try to focus and understand. This is not at all a difficult program, is very easy program. So I am creating array A of max. So this is what is my hash table now. Okay, so the size of the hash table. So I'll be reading the employee ID. What I'm saying now, I'll be reading it to the num represents the employee ID, and key is the value that will be returned by the hash function, and I for the looping purpose. Okay, and then answer is equal to 1 because for repeating purpose. So I do this, and I'm just prompting on the screen collision handling by linear. This is a program to handle the collision by linear programming. This message I'm printing on the screen. After that, see, for I is equal to 0, I less than max, so I initialize all the elements of my array initially to -1. Hope you people are following. Now from a of 0 till a of 99, I'm initializing them to what? Hello?
-1.
-1. Next, so I'm running a do while loop. Now enter the data. Enter the data, or you can also say enter the employee ID to be more meaningful. Okay, data here is nothing but the employee ID. Enter the employee ID. I'm reading the employee ID to what? Num. Okay, and the employee ID what you read, it should be of length how many digit? 4 digit. So don't give more than 4 digit. So the employee ID what you enter, it should be of length 4 digit. And after that, for that employee ID, you got to find the hash key. Now in order to find the hash key, I'm making a call to create by passing the employee ID, 4 digit employee ID. Now let us go to the create function. See, create is very simple function. So in create, so I'm taking a local variable with the name key, and num modulus 100 I'm doing. So I'm for doing the simple division method or simple division. So this hash function is what kind of a function it is? It is a division type function. Okay, where yesterday you understood various types of hash functions, and this was the first type among them what we discussed. So num modulus 100 is equal to key. Okay, say for example the employee ID is 1234. Okay, I have the employee ID of 1234. Say this is the employee ID, and what this is going to return me is 34. Okay, so the key value will be 34, and then that is what I'm returning. 34 will be returned. Correct, right?
Yes, sir.
Okay, so 34 is the key, remember. Now I have to insert this 1234 at the index value 34 in my hash table. So return key, and that key gets assigned to this key. Now this key is 34 right now. Next, I make a call to linear probe. I'm passing the complete array. I'm passing the key 34. I'm passing 1234, which is the employee ID. 34 is the key, 1234 is the employee ID, and A is the complete array. Now let us go to the linear probe. So linear probe, you can observe here. So array, so this is my key 34, and this is 1234. So I have taken flag is equal to 0, I count is equal to 0, all these things. When we go to the program, we'll understand why flag is used, count is used, all those things. Now what I'm checking before inserting, correct? No, I got to check whether the 34th index in the hash table is blank or not. Okay, so I'm checking A of 34. If it is equal to -1, what does it mean? Is it available or not available? Available it is, because so I have already initialized all the elements of my array as -1. If it is -1, what does it mean? There is no employee record present in that particular index. Now A of 34, when I equate it with -1, yes, it is true. Now I have found, so the employee number 1234 must be stored at the position A of 34. Correct, right? Hello?
Yes, sir.
At the index 34, you have the employee information 1234 stored. In case when you are checking A of 34 equal to -1, if it is not equal to -1, what does it mean? So at that particular index, there is some employee information already present, or some employee record already present. Yes or no?
Yes, sir.
In case if the key is not equal to -1, some employee record is already present inside that at that particular index within the hash table, then you come to the else part. Okay, come to the else part and display the message collision is detected. Now you have to go for handling that collision by using the linear probing technique. Now how? This is how we do. So for I is equal to 0, I less than max, I plus plus, I am just checking if A of I not equal to minus 1. Okay. So I keep doing, and wherever it is not equal to minus 1, I go for incrementing the count. Okay. So if it is not equal to minus 1, I increment. That means if it is not equal to minus 1, what it means? So all those indexes within the hash table are already filled with some employee information. So finally, when this loop gets executed, the count will give you, so the number of filled rows within the hash table. Hope you understood.
Yes, sir.
Next, so printf. Okay, I just say the collision is avoided successfully by using the linear probing. So this count I'm finding, and then avoided by linear probing successfully, and I go for checking if count is equal to max. If the count is equal to max, count is also 100 and max is 100. What does it mean? All the rows in my hash table are already filled with the employee records, and then it will say the hash table is full, and then it will call the display function. So it will display the option for you to go for displaying the entire hash table or display the filtered hash table. So hope it is clear.
Yes, sir.
Okay, and then we are exiting from the program itself. So hash table is full, so just provide him the display option, provide the user with the display action, and exit the program. In case if count is not equal to max, okay, count is not equal to max, that means what? There are empty locations within the hash table, and you can still go for inserting the element. So we skip this and we come to this part. Now I is equal to key plus 1. Okay, I am initializing I to key plus 1 from the point where, say for example, let me take this. So this is where when I found I have got the key as, say for example, I have got the key as 5. Now what I will do in linear programming, I don't search in this direction, I will be searching in this direction, correct, right? So next I look for the empty location here, next I look for the empty location here, here, and finally when I reach overflow, then again I move back. Okay, same thing what we are trying to do here. See, that is the reason I is initialized to key plus 1 more than that. So if this is your key, so I should be initialized to 1 more than that, that is 6. Hope you understood.
Yes, sir.
Until it is less than max. Okay, I check if A of I is equal to minus 1. So I am looking for the empty location. If it is equal to minus 1, what does it mean? It is an empty location. Yes or no?
Yes, sir.
You found an empty location, and if you found an empty location, so at that location you go for inserting the employee record and make flag as 1. So indicating that this has already taken its position, and break the loop. Okay, break the loop. So next I have one more for loop here. Say I start from this, I look whether this is empty, no, not empty. I look for this, whether this is empty, no, not empty. I look for this, whether this is empty, no, not empty. I look for this, whether this is empty, no, 9 is already there. Now what has happened? I have reached overflow. Okay, next what I have to do? I have to start searching from here, from the beginning. Now that is what we are doing here in the next parallel. See, I am initializing I to 0, and there is one more condition is this. 2 conditions are there. I is initialized to 0, I should be less than key. So let me go back here. See, we started from here, and from here we have already checked. Now from when I am starting all the way from the beginning of the hash table, from here to here I need to check. I have to stop at this point. OP people are following?
Yes, sir.
Okay, that is the reason this condition. Now I is equal to 0, and I should be less than what? Key. Okay, and one more thing, flag should be equal to 0. Okay, so in case if the empty location is found, so flag will be made as 1 here itself. Okay, and I plus plus. So and again I check. So I'm checking in this portion of the hash table right now. I'm checking the empty location in this portion of the hash table. Okay, if it is found, again I go for assigning the num there and then make flag as 1 and break the loop. So that's it. This is what is the linear probing. Hope you people understood.
Yes, sir.
Okay, it's a very easy program it is. Okay, now so the other one is display. I'll come to here. See, linear probe, and then after linear probing and inserting the element, it will also show you. In case if all the locations of the hash tables are filled, it will say it is full. Okay. Now, do you wish to continue? It will ask. So, if you say 1, it will continue reading the employee ID of one more employee. If you say 0, it will stop. Okay. So, 0 or 1, yes or no. 1 is nothing but yes, 0 is nothing but no. Okay. So, answer is yes, we keep repeating. Okay. So, while answer is 1, so we go back and repeat. And display. Okay. Whenever I say 0, it will come out and make a call to display. We'll go to display now. So, look into the display function. What I am passing is the complete hash table. Array I am passing. And then display all and filtered display. So, what is display all is? Displaying the entire hash table. So, when I say for example I have added 5 employee details and I am saying display entire hash table, it will start displaying the hash table from the 0th index till the last index, 100th index. Okay. So, you can see 5 employees data will be there and the rest all will be what? -1. Now, what is a filtered display? So, I want to display only those indexes which are storing the employee record. Say I have entered 5 employee records. Now, I want to display only those 5 employee records and the rest all which are not filled with the employee records, I don't have to display. Okay. So, then I go for using the option 2. Hope it is clear.
Yes, sir.
Okay. I am reading the choice. Say if choice is 1, the hash table is, see, for I is equal to 0, I less than max, I am printing everything. I am printing the key also, I am printing the value also, ID of the employee. Now, else, if choice is not 1, display all. Okay. Choice 1 is display all. If the choice which I am choosing is not display all and if it is a filtered display, so you can add a statement, filtered hash table is, so for I is equal to 0, I less than max, I plus plus, see, I go for printing only if it is not equal to -1. If it is equal to -1, I skip that. Okay. So again I go for printing the hash key and also the ID of the employee and then continue. Hope you understood?
Yes, sir.
Okay, that is the program. The whole program, entire program is only this much. So we'll go for the execution now. So I think the yesterday's batch has missed executing this 12th program, but at least today's batch can execute, and I request the batch which has completed the DS lab yesterday to execute their on their own self-interest today after all your classes finishes. Sit at home and go for executing. So now we'll see the execution first and then we will trace the program. One second. Oh. Just a minute, I'll open it again. Okay, it's running. I'll open the program again. Okay. Lab program and the 12th program. Okay. The same program which I explained to you people now. So collision spelling is wrong, let me correct it. And then so choice 1 is the complete hash table what we are displaying. So you can just say complete hash table, and this one you can say filtered hash table.
Sir, what is the point of putting
louder please.
What is the point of putting the continuous, sir, in the for loop for filtered hash table?
One second, I'll come to that. Okay. For I is equal to 0, I less than max, I plus plus. If it's not equal to that, print it, and then it's not necessary actually. What continue does, it will make you to continue with the next iteration. So even if you're not writing this continue, obviously it will go and continue with the next iteration.
Okay, sir.
Yeah, it's not necessary. Even if you write and even if you comment this, nothing is going to happen. Understood?
Okay, sir.
Say, in case if you want to skip the current iteration and continue to the next iteration, then continue is required. Now what will happen is, it will check this condition. If the condition is not true, okay, so these two statements are skipped and it will all the way go to the next iteration. Okay, and if the condition is true, then it comes here, prints. After printing, obviously again it should go back and continue with the next iteration until as long as this condition is true. This statement, as of now, I think it is not necessary, and even if you write, nothing will happen. Now obviously after printing this, when the continuous statement is executed, obviously it should go to what? The next statement. So implicitly it will go to the next iteration if you remove this. Now you are explicitly telling, go to the next iteration. Nothing will happen. Okay.
Okay, sir.
Okay. So it's like instructing the person who voluntarily does his assignment to do the assignment. That's all. It doesn't matter. Even if I don't tell him, he'll do his assignment. Something like that. Okay. Now we'll run this. Control F9. Okay. Collision handling by linear program probing, it is displaying. So let us go for adding the data. So instead of saying data, I should have taken this as employee. Okay, employee ID, something like that. It's okay. Later we will change it. So 1 2 3 4. I'm adding 1 2 3 4. Now can you tell me what is the hash key that will be generated for this?
34.
34. That means this employee record will be stored at the 34th index in the hash table. Okay, so you can take a piece of paper and you can start writing if you want. So at 34th index we have 1 2 3 4 stored. Okay, then let us ask me, do you want to continue adding one more record, one more employee record? Even this also we will change the display name. Do you wish to add one more employee, something like that? So 1. Okay, I'm interested. Now I'll give 4 3 2 1. Okay, I'm adding an employee with the number 4 3 2 1, and where this gets inserted? At 21. So 4 3 2 1 at the index, so 21. So the 4 3 2 1 gets inserted. Okay, now again, do you wish to continue? Yes, I want to continue. I'll give 1199, enter. So where this 1199 gets inserted? 1199 gets inserted at the index 99. You have 1199 stored. Now what I'll do, I'll just say again, yes, I want to continue. and I'll give 1 2 3 4. Okay, now 1 2 3 4, what is the key that it is going to generate?
34.
34. Okay, instead of 1 2 3 4, let me take it as 2 3 3 4. Yeah, 2 3 3 4. Now what is the key it is going to generate? 34. But at index 34 there is already the employee record 1 2 3 4 stored. Yes or no?
Yes, sir.
Now it should say collision detected and collision avoided successfully using linear probing. That means once it detected the collision, and is the ash table full? No, it is not full yet. Now it's saying collision detected and the collision successfully avoided by using linear probing, and it is inserted to the next empty location. It is inserted because the next empty location was at 35, right? See, we have 34 at index 34, 1 2 3 4 stored, and the key generated is also 34 right now. What is the next index after 34? 35. That means this 2 3 3 4 get stored at what index?
35.
35. At 35 you have 2 3 3 4 stored. Okay, do you wish to continue? I'll just say no. Okay, enough. Now it is giving me the display. Okay, you have added the records. If you want to view, go for viewing. Let me go with the display all. Okay, so since we have 100 employee record here and I am using the Turbo C, I cannot scroll up and show you. What I can show you is the last few records. One I press. Okay, Alt F5. See, so from 75 to 99, and before that I cannot scroll. This I cannot scroll. Okay. I think I can try by minimizing it. Oh no, even then it is not possible for me. Okay. Yeah, say 99, I have 1199 stored. If you have written, you can observe this, and the rest all are filled with what? -1. What -1 indicates here? They are empty. Okay, now I press enter again. Yeah, now Alt F5. Okay, sorry. Okay, now let me press Control F9 again. Enter the data. Let me go again for the second time. So same thing, I'll input 1 2 3 4. Do you wish to continue? Yes. And then 4 3 2 1. Do you wish to continue? Yes. And then 1199. Do you wish to continue? Yes. And then 1 2 3 4. Not 1 2 3 4. 2 3. So let me not make them collide. So employees' IDs will be different, right? 2 3 3 4. Let me take. So collision detected, collision avoided successfully using linear probing. And do you wish to continue? No. Now filtered display 2. I'll go. Alt F5 I'll press. Say filtered display. You can see now 21. You have 4 3 2 1 stored. 34 1 2 3 4. 35 2 3 3 4. And 99 I have 1199 stored. Is that clear?
Yes, sir.
Okay. See, here there was a collision for storing 2 3 3 4 was a collision because 34 was the key generated. At 34 1 2 3 4 was already stored. Now it started using the linear probing. So it just tried finding the next location. 35 was empty. Now it got inserted there. So if the same thing continues, okay, and if it reaches overflow, and again the second for loop which was there in our program, that will be called, and it will all search from the 0th index till the key is less than I is less than key. Okay, so this process, and even there also, if there is no empty location found, and then it says the ash table is full. Correct, no?
Yes, sir.
Now I hope you people understood the advantage of building the ash table. Searching is much faster. Correct?
Yes, sir.
Now just compare this with the normal arrays. Okay, hash table with the normal arrays. If you want to look for if you want to find any element within the array, you have to start all the way from the beginning, and you got to do linear. One by one you have to search. No sir, I don't want to use linear. Otherwise you have to use binary search also. Even in binary search also, you have to recursively keep searching by dividing the given array into subarrays, correct, no, until the element is found or the low value crosses the high value. But here, given a key, say for example, I ask you to search this the employee record with 4321. What is that you'll do? You'll apply the hash function, you get 21, you'll directly go to the index 21. So there the employee record should be there. If the record which you're looking for, if it is not there, at least it will be there in what? The next row or next to that. Understood?
Yes, sir.
Okay. So this is what is the last program and the easiest program. So the one thing here is the question for the 12th program, when you look into that, you'll get panic. So this is the easiest program. Okay. So now the batch which has the lab now from 11 o'clock can go for executing this program. So you take some time, you can join by 11:20, no problem, but before joining, make sure that you are going to write this program in your observation copy. Just write it down. Now only I'll upload it to the Google site. So I think I need to debug. Do you want me to debug this program, or you'll debug by yourself?
We'll only do, sir.
Yeah, I think
We'll do it, sir.
yeah, debugging is not necessary. You can do by yourself. Now I'm quitting this and do the messages, right? You write them appropriately. So enter you can take it as employee, you can just take it as ID. Okay, employee ID. And do you wish to continue adding one more employee ID, and then I'm not done these changes in my program, but you do that. Okay, this is in the manual, and then okay, this is hash table is full, that's fine. In the display, complete hash table, and this is the filtered hash table. I've written it here. Okay, and the continue is not necessary. You can remove this. Okay, then let me mark the attendance.